We have another definite integral, and I think it often makes sense to rewrite this 10 in the denominator as a 1/10. I think to a lot of students that looks better. Now, we still have not formalized our process of integration here. We're going to do that very soon when we start talking about substitutions. But to do both of these problems, maybe we can think about a function whose derivative is just regular old e to the ax, a just being some constant. And you might think, well, how about e to the ax? I know that the derivative of e to the ax is e to the ax. But then you remember that there's a chain rule, and the chain rule says that you have to multiply by the derivative of ax, which is just a. Well, that wasn't the original question. We want a function whose derivative is just e to the ax. So what you can do is divide both sides of this by a, and there it is. We found that the function 1 over a, e to the ax, has a derivative of e to the ax. We can rewrite this in an integral form. If we want to now integrate e to any constant x, that is just e to that constant x divided by that constant. So back to this problem, maybe not to belabor this more than it needs to be, but we can do a very simple rewrite of this power here. Instead of calling it x over 2, we can call it 1/2 x. Then I think this form more clearly shows us that we have an a times x up in the power of e on both of these parts. That corresponds to this integral that we just came up with over here. So to do this integration, we just pull out the 1/10 first. We have e to the 1/2 x as our integral, but then we have to divide by that 1/2. So you could call this 1 over maybe 1/2, something like that. With this e to the 5x, we just copy down the e to the 5x, but we have to divide by that 5. Put a plus c on there and simplify, and we will be finished. Remember that when we have a fraction in the denominator, we can flip it over and put it up in the numerator, and we can simplify that fraction, and we are now finished with this problem. Now, I promise that soon we're going to formalize this process of integrating. Instead of just playing around with functions and trying to figure out a function whose derivative is whatever you're trying to find the integral of, we're going to come up with a process typically called u substitution that I guess is going to give us a little bit more of a step-by-step way to find these integrals. But for now, we're finished with this one.